Hello students. Now, so let us start the second unit, that is a Laplace transform. So first we'll understand the basic definition of Laplace transform, and then we'll discuss the Laplace transform of some standard functions. Okay. So what is the definition of this Laplace transform? This is very important to know about the definition, because with the help of definition you can find out the Laplace transform of any function which is defined for all t greater than 0. Okay. So let f of t be a function. Let f of t be a function defined for all t for t greater than 0. Okay. Then what is the Laplace transform of f of t? Then Laplace transform of f of t is nothing but, it is denoted by what? Laplace of f of t. This is the notation and is defined as, how we define this? This is here, Laplace of f of t is equal to, this is actually integration from 0 to infinity e raised to minus st into f of t dt, and this is also called as what? Capital F of s, where s is a parameter. Okay, so this s is what? S is a parameter here. This is the basic definition of Laplace transform. So with the help of this definition, one can find out the Laplace transform of given function f of t. So L is what? So some informations are here. So what is that L? So first thing is what? L is a Laplace transform operator. This is operator, Laplace transform operator. This this if this integral is exist and finite, then and then the Laplace transform f of t is exist, and what that operator, it may be s is actually the parameter which is either real or complex. So this is real or either it is a complex. Okay. So let us see the Laplace transform of some standard functions. So some function, now we are going to discuss some standard function and how we can define the Laplace transform of that function. Let us see. Okay. So first, Laplace transform of some standard function. Laplace transform of some standard function. So let us take first function as the first result. Suppose if f of t is equal to 1, okay, then what is the Laplace transform of this? Suppose if f of t is equal to 1, now just use the definition. So what we have, Laplace transform of f of t is equal to integration 0 to infinity e raised to minus st into f of t dt. This is my basic definition. Suppose if I want the Laplace transform of 1, replace f of t by 1. So what we get? It is 0 to infinity e raised to minus st into f of t is nothing but 1 into dt. Am I right? So now integrate this e raised to minus st. If we integrate it, what I get? E raised to minus st divided by minus s. It is from 0 to infinity. Now apply the limits. So for upper limit, if we have e raised to minus infinity is equal to 0 and e raised to 0 is equal to 1, with the help of these two values, we can find out the answer. So if we apply the upper limit, what we get? It is 0 minus, for lower limit e raised to 0 is 1 divided by minus s, and minus minus become plus. This is equal to 1 upon s. Okay, and this is my result. So this is Laplace transform of 1 is equal to what? 1 upon s, where s is greater than 0. So this is the first result that I have. It is a very basic result, and there may be a question in your online exam, maybe related with this. So what is the Laplace transform of 1? So this is my Laplace transform of 1. It is 1 upon s. Four options are there, isn't it? So let us move forward with the second rule. What is the Laplace of e raised to at? Suppose if my function is f of t is equal to e raised to at, then what is the Laplace transform of this function? Okay, so the Laplace transform of e raised to at is nothing but, again use the definition. What is the definition? Laplace transform of f of t is equal to what? Integration 0 to infinity e raised to minus st into f of t dt. Replace the value of f of t as e raised to at. So Laplace of e raised to at, this is equal to integration 0 to infinity e raised to minus st into e raised to at into dt, isn't it? And now what I have here, just I just make simple adjustment here. So 0 to infinity e raised to, I'll just minus a raised to m into a raised to n. The result we have a raised to m into a raised to n is equal to a raised to m plus n. So what will happen with the with this? It is e raised to minus st plus at into dt. So we can take here minus sign common in the power of e, and it become s minus a into t dt. And now we can integrate it. It is very simple. Okay, and now if we integrate this, what I get? 0 to infinity, sorry, just take the integration. So what is the integration? E raised to minus s minus a into t divided by, it is s minus a, this is minus, it is from 0 to infinity. Now apply the limits, again use the same values that we have used in the previous result. It is e raised to minus infinity is 0, e raised to 0 is 1. If we apply the upper limit, what I have it is 0 minus, for lower limit it is 1 upon is minus s minus a. Okay, and minus minus become plus, this is 1 upon s minus a, where s is greater than 0. This is my second rule. So therefore Laplace transform of e raised to at is equal to simply 1 upon s minus a, where s is greater than 0. This is my second rule, that is very important also for the online as that of previous. The same, the question will be there in your online exam related with this. What is the Laplace transform of e raised to at? It is simply 1 upon s minus a, isn't it? Now suppose if we take similarly the next rule that we have, Laplace transform of e raised to, what is that? Similarly, Laplace transform of e raised to minus 80. Instead of 80, if there is minus 80, then its Laplace is simply what? 1 upon s plus a. S is greater than 0. We are just replacing s by a by minus a. That is the only change over here, and that is the formula that we have. Okay. Suppose similarly, if we take the Laplace of next function to find, suppose fourth rule that we have, suppose if my f of t is equal to sine of at, then what is the Laplace of this function? Again use the formula, Laplace of f of t, this is equal to 0 to infinity e raised to minus at into f of t dt. Replace f of t by sine at, Laplace of sine at is equal to integration 0 to infinity e raised to minus at, sorry, it is e raised to minus st, not at. This is e raised to minus st into f of t is nothing but sine of at dt. Now very basic result from the integration that we have, integration e raised to ax into sine of bx is what? So this is nothing but what? It is e raised to ax divided by a square plus b square in bracket a sine of bx minus b cos of bx. This is the result. Now we are going to use this rule here. Okay, so this is my a, minus a is nothing, s is nothing but a, and your a is nothing but b. Okay, so if we apply the rule for above integration, so the integration Laplace of sine at is nothing but what? This is equal to e raised to minus st divided by minus s square plus s square in bracket a means minus s into sine of at minus a into cos of at, and it is runs from 0 to infinity. Now apply the rules limits. Okay, so if we apply the upper limit, I'll get 0 because e raised to minus infinity is 0 minus e raised to 0 is 1, so therefore 1 upon s square plus s square is there in bracket sine 0 is 0, therefore this term become also 0 minus a into cos 0 is 1, therefore minus a is there, and minus minus become plus, therefore it is a divided by s square plus s square, where s is greater than 0. Okay, so here s is greater than a, not 0. Here also s is greater than a, not 0, that otherwise it become minus. So this is the Laplace of sine at, and therefore what? Therefore Laplace transform of sine at is equal to what? A divided by s square plus s square, where s is greater than 0. Isn't it? So hope you understand this. This is the Laplace of sine at. Okay, so if you want Laplace transform of cos at, so similar, in the similar way you can find out that. Okay, so the fifth rule is Laplace transform of cos at is nothing but what? S divided by s square plus s square, s is greater than 0. Okay, so in the similar way, sixth rule that we have, Laplace of what is sine hyperbolic at. So just the only change is what? See, in the sine at it is a upon s square plus s square, here it is a upon s square minus s square, where a is greater than minus of a, mod of a, minus plus a is there. Seventh rule is Laplace of cos hyperbolic at, the only change is what? S divided by s square minus s square. Okay, again s is greater than mod a. This is the only change here that we have. Okay, and one more rule related with this standard function is, what is the Laplace transform of t raised to n? So this is nothing but gamma of n plus 1 divided by s raised to n plus 1 for s greater than 0, n greater than minus 1, and this is simply what? N factorial divided by s raised to n plus 1 for s greater than 0, n belongs to positive integer z, like this. So what is the gamma function actually? So one note is here. So rules of gamma function. Note that, so my note is gamma n plus 1 is nothing but what? N factorial. If n is an integer, positive integer. For example, suppose if I want gamma 5, what is gamma 5? It is nothing but gamma 4 plus 1. 5 is nothing but 4 plus 1, and this is 4 factorial. And 4 factorial is nothing but 24. Okay, the product of the numbers from 1 to 4. And another result that we have, n plus 1, this is equal to n into gamma n. We widely use this result actually generally if n is your rational. Suppose if I want gamma of 3 by 2. What is gamma 3 by 2? It is nothing but gamma 1 by 2 plus 1. And it is nothing but 1 by 2 gamma 1 by 2 in this way. But gamma 1 by 2 is nothing but what? Root pi. The answer of this is nothing but 1 by 2 into root pi. That result also we have, gamma 1 by 2 is nothing but what? Root pi. This is the improper integral actually. Gamma function is nothing but improper integral. Those who have come from the first year engineering, so they actually know about the gamma and beta function. Okay, so this is about what? This is about the uh, basic definition of Laplace transform, and what we called it as the